All right, so 4-5, you're welcome. 4-5 is sine and cosine curves. So a refresher on sine curves. Again, we did these last year for sure, but we're going to go back to them, be a little bit more specific. So on the sine curve, how this gets formed is if you took your unit circle. So I'm going to grab mine just so we can see where this comes from. If you took your unit circle and you isolated out just the sines, so just the y coordinates. If I made the x-axis my angle in radians and the y-axis my sine, then I end up with this curve. So at 0, my y is 0, which means that coordinate point is there. If I jump to pi over 2 at the top, pi over 2, my y is 1, which is why that point is there. At pi, my y comes back down to 0. At 3 pi over 2, it comes to negative 1. And then if I come back around to 2 pi, it's back at 0. So that's where the overall shape of the sine curve is. And this is like the parent function of sine curves because we're going to eventually move these around. But that's where this curve comes from. You have to remember that sine takes on, it's almost like an S shape-ish, okay? Sideways, flipped over, whatever, but it's like that shape. It starts at 0, it goes up to what we call the amplitude. It comes back down to 0, down to the negative amplitude, and then back up to 0. It takes one full period, which in the parent function is 2 pi, to make one full curve because it would take one circle around your unit circle to complete it for your standard sine curve. If we continued on that pattern, we can create an infinite amount of cycles. So this does not end, even though we only graph a certain amount of periods, either 1 period or 2 periods. It would continue on forever and ever in that way. So this has 3 full cycles. So if it asks for 1 period, it's like this. This would be another one. If I go negative, it doesn't matter which direction you go. That would be a third one. Notice that with your sine curve, it never gets to be greater than 1 or less than negative 1, and that's because your y values are the same. They never get bigger than 1 or less than negative 1. The first thing we're going to identify from our equation is the amplitude and the period. The amplitude is the absolute value of A, and A is the number on the front of the curve. So if it's a negative 2, that tells you it's reflected, but the 2 itself is your amplitude. It's half the distance between the maximum and minimum values of the function. It is how high up we go, and it is how low we go on our curves. That's the amplitude. Then we're going to identify the period, and the period is how long it takes to make one full S of curve. So it is 2 pi over b, and b is what's in between the trig function and the variable and the x. So it could be a whole number, it could be a fraction, it could have pi, it could have constant. There could be a lot of different things in there. But you just do 2 pi over that, simplify it, and that's the period. This is like sort of the steps to graphing. I do it a little bit different, but I'll talk about it when we get there. The first one is right. I'm going to do the amplitude, which is the absolute value of A, and the period, which is 2 pi over b. So step 1 is always that. Now, step 2, you can do in 2 different ways. You can either figure out what a quarter of the period is and add it to the key points, or you can take the period and you can multiply it times 1/4, 1/2, and 3/4. And that's what I'll recommend that you do. So once you identify the period, you're going to take that period and you're going to multiply it times 1/4, times 1/2, and times 3/4. And honestly, it's just because people tend to make less mistakes when they multiply fractions than when they add them. That's all. Those are going to be your middle 3 key points. The first one, without a phase shift, which we'll talk about in a little bit, is at 0. And the last one is the period. And that would be the x values, or the x values of your key points. So they'll literally get marked on your x-axis. Key point, and key point. Then you'll mark your y, and your y will be based on your amplitude. So we'll go up to whatever the amplitude is, and we'll go down to the negative amplitude. And then you'll literally draw your curve by connecting the points. 'for one full period. If it wanted an additional period, you would just extend the points in either direction using the same intervals. You remember this? Yes? Okay. All right, let's go to an example. So the first thing I'm going to do is identify that this is sine, because obviously it's going to change, and sine is that S shape. Then I find A. A is what? 2, and that means my amplitude is the absolute value of that, which is also 2. The B is what's in between the trig function and the x. What's there? A 1, which means the period is 2 pi over B, or 2 pi over 1, which is 2 pi. There is no phase shift. If we add or subtract something in here, there's going to be a phase shift. We're going to get to that in a little bit. There's no phase shift, so I'm going to take my key point that started at 0, and then do the next one at 2 pi times a fourth, the next one at 2 pi times a half, the next one at 2 pi times 3/4, and the last one is the period, which is 2 pi. So this simplifies to be pi over 2. This simplifies to be pi, and this simplifies to be 3 pi over 2. Then I'm going to draw my x and y axis, and I'm going to mark those 5. It has to be 5 key points on the x-axis. So the first one is at 0. The second one is at pi over 2. The third one is at pi. The fourth one is at 3 pi over 2. And the last one is the period, which is 2 pi. Then I mark my amplitude, which is 2. So I'm going to go up 2 and mark it, and I'm going to go down 2 to negative amplitude and mark that. And then it's sine. So I start at 0, 0. I go up to the amplitude, come back down to 0, negative amplitude, and back up to 0. And that is one period of this sine curve. Again, if it wanted more, I would just extend it in the same increments and follow my pattern on either side. Yeah, Anya. The B is what's in between the trig function and the variable, so there's nothing there, which means it's a 1 this time. Questions? All right, what changes this time? Just the amplitude. So everything else is the same. My key points, my B is still 1, which would mean my key points are going to stay the same. They're going to be at 0. They're going to be at pi over 2. And if you look at, this is like a standard period of 2 pi is based on the quadrant angles of your unit circle. 0, pi over 2, pi, 3 pi over 2, and 2 pi. The only thing that changed is my amplitude. So if this was 2, if we had marked 2 and negative 2, we got to cut it down so that it's a half and negative a half. And then I still start at 0. I go up to the amplitude, come back down to 0, negative amplitude, back up to 0. All right, now what's changing on this one? The B is different now, right? Your amplitude is also different, but the B is different now. The B is 2. So my A is still positive. It's still 3. My amplitude is still 3. The B is 2, which means the period is 2 pi over 2, which means my period is pi. So from start to finish, it would take up half the distance of the last ones if we overlapped them. I start at 0, and then I do pi times a fourth, pi times a half, pi times 3/4, and the last one is the period, which is pi. So pi over 4, pi over 2, 3 pi over 4. And amplitude is 3. Now, if I overlap this on top of the last graph, it would have to be half its distance. It would have to be squished a little bit more. But because you're marking these, I don't care if it is perfect, as long as you're consistent with your spacing. So technically, this would be a little bit more narrow than the last one. But again, it doesn't have to be perfect. As long as you mark your key points, it's fine. Now I start at 0. I'd go up to 3. I'd come back down to 0. I'd come down to -3, and I'd come back up to pi. All right, this one just says determine the amplitude and the period of the following function. So what's your amplitude? 3, good. What's b? Pi. So my period would be 2 pi over pi, which is 2. So your key points would be at 0, a half, 1, 1.5, and 2. They do not have to have pi in them, okay? We're not going to graph it all the way out because I think you're okay, right? Yeah. But no, just because your key points don't always have to have pi in them. Okay, now what happens with a phase shift? A phase shift is a horizontal shift. It's going to take your graph and shift it to the right or to the left. And it happens if you have something adding or subtracting inside the parentheses, because outside would be a vertical shift. And it's always the opposite you think, just like a horizontal shift. If I had x plus 2 in parentheses squared, then I actually shift that to the right too. It's the same concept. You're going the opposite direction. So to find your phase shift, you're going to take whatever's inside the parentheses, you're going to set it equal to 0, and you're going to solve. It will change its sign. And then that value is your phase shift. So then what you're going to do is do everything we just did. Find your key points, so whatever the key points are. So let's just say it's 0, pi over 2, pi, 3 pi over 2, and 2 pi after you do your quarter, half, all that stuff. And then let's say that this says x minus pi inside here. That means my phase shift is a positive pi. So after you find your key points, you're then going to add pi to each of them. If it was a negative pi, I'd subtract pi to each of them. And what happens is it literally takes your curve and it shifts it, so you're no longer starting at the x being 0. You're starting where the x is your phase shift. So after you find your key points, then you add the phase shift or subtract the phase shift from them, depending on if it's positive or negative. All right, so example 5. Determine the amplitude, the period, the phase shift and of the following, and then graph it. So start with what we know. A is what? 2, and my amplitude is 2. B is 4. So the period is 2 pi over 4, or pi over 2. And this time there's a phase shift because we're adding or subtracting something inside the parentheses. So I'm going to set this equal to 0. 4x would equal negative pi. Divide by 4, and x equals negative pi over 4. That's your phase shift. So once I get all my key points, I'm going to subtract pi over 4 from each of them. With me so far? All right, so here comes the key points. The first one is at 0. The next one is at pi over 2 times a fourth. The next one is at pi over 2 times a half. The next one is at pi over 2 times 3/4. And the last one was the period, which is pi over 2. So I get pi over 8, pi over 4, 3 pi over 8. And now we shift them negative pi over 4. So I subtract pi over 4 from each of them. The first one will always be your phase shift because it was 0 plus or minus whatever it is. So it's negative pi over 4. Now I got to give like denominators. So pi over 4 becomes 2 pi over 8. So this is negative pi over 8. Pi over 4 minus pi over 4 is 0. 3 pi over 8 minus pi over 4 becomes, the pi over 4 becomes 2 pi over 8 again. So this is pi over 8. And then pi over 2 minus pi over 4 multiplied by 2, and I get 2 pi over 4 minus pi over 4, which is pi over 4. And now these are your 5 key points. Note this time I've got negatives in here, so I want to make sure I give myself room to the left and to the right of my y-axis. So I have a key point at 0, and then I want to go negative pi over 8, negative pi over 4, so they're equally spaced. Then go back the other way, positive pi over 8, positive pi over 4. Amplitude is 2. And I'm still on sine, so I start at 0. I go up to 2, down to 0, down to negative 2, up to 0. So that one had an amplitude stretch, a phase shift, and a period compression, really. All right, we're just going to start it. We're not going to go all the way through. What's your amplitude? 1/2. Your B is what? 2. So the period would be 2 pi over 2, which is pi. Is there a phase shift? Yes, there's something being added or subtracted here. So I'd get 2x minus pi over 2, set it equal to 0. Add the pi over 2, 2x would equal pi over 2. And then divide by 2, which is the same thing as multiplying by 1/2. And I get a phase shift of positive pi over 4 this time. So all my key points, which would be at 0, at pi over 4, at pi over 2, at 3 pi over 4, and at pi, would now get added pi over 4. And then my graph would start at pi over 4, and it would end at 5 pi over 4 with an amp at 1/2. So again, I won't go all the way through, but you kind of get the point. Are you good, or do you need me to go all the way through that? Speak up. Going once, going twice. We're good? Okay, so if I add 0 and pi over 4, I get pi over 4. If I add pi over 4 plus pi over 4, I get 2 pi over 4, which is pi over 2. If I get pi over 2 plus pi over 4, I have to change it so that pi over 2 becomes over 4. So this would be 2 pi over 4 plus pi over 4, or 3 pi over 4. 3 pi over 4 plus pi over 4 would be 4 pi over 4, which is pi. And then 4 pi over 4 plus pi over 4 would be 5 pi over 4. So pi over 4, pi over 2, 3 pi over 4, and pi. First one's the phase shift, last one's the period with the phase shift. and it's sine. So we start at 0. We go up to the amplitude, down to 0, negative amplitude, 0. All right, so the good news is with cosine, it is almost exactly the same. Every single step is the same until you graph it. The difference with cosine is the overall shape changes because the cosine is based on the cosine of your unit circle or the x-coordinate on your unit circle. So again, I'm going to pull in that unit circle. If I isolated the angles as my x values, that's what's going on the x-axis. These are the angles around your circle. And instead of looking at the y this time, I looked at the x at 0. It's 1, which is why it's up at the top here. At pi over 2, it's at 0, which is why it comes back down. At pi, x is negative 1, so it's below the x-axis. At 3 pi over 2, it's back up to 0. And at 2 pi, it's back up to 1. And so the cosine takes like this V-ish shape, kind of maybe a sideways C, if it helps you remember it that way. But it starts at the amplitude. Still has the same range. It still can't go higher than negative 1 or smaller than 1 for your parent function. If we shift this up or down, that changes. But for your parent function, that's the same. And the period is still the same. So we still do all the same steps until you get to the end of it. So this has a negative on it. We're going to first talk about it as though it was positive. We're going to graph it, and then we're going to say what would happen if it switches. So does the A, technically that A is a negative 2. My amplitude is always the absolute value, so it's positive 2. What's the B? 4. So the period would be 2 pi over 4, God bless you, or pi over 2. Is there a phase shift? No, there's nothing adding or subtracting inside the parentheses. So now I'm going to find my key points. The first one's at 0. The next one is at pi over 2 times a fourth. Then pi over 2 times a half. Then pi over 2 times 3/4. And then pi over 2, or the period's the last one. So pi over 8, pi over 4, 3 pi over 8. And these are my 5 key points. Zero, pi over 8, pi over 4, 3 pi over 8, and pi over 2. If I put this on like a standard graph, this would be really squished. Our curve would have to get completed in 1/4 of the horizontal distance that our normal one does because this is squished. But if you are the one, if you're the ones, like when you do homework, it's a PDF, you're going to see you are the one drawing your graph out. You are the one that's working on your spacing. So as long as your key points are labeled correctly, it's fine. Okay, so now, again, we're going to graph it as though it's a positive 2. So if it's cosine, instead of starting at 0 and going up to the amplitude, we start at the amplitude. So it would be at positive 2, comes down to 0, negative 2, up to 0, and up to positive 2. And don't make it a V, make it have curved edges because it would continue on to be curved. If I wanted it to keep going, I could literally drop it down on either side and continue my pattern. You with me so far? So that's if it's a positive 2, but it's not. It's a negative 2, which takes and flips your graph upside down. So instead of starting at positive 2, we actually start at negative 2. We still come to 0. Then we'd go to positive 2. We'd come back to 0, and then we'd go to negative 2. So your curve looks like this instead of the purple one. Oh, this would be your answer. Good? Yes? So if it was a sine curve with a reflection, instead of starting at 0 And going up, you'd come down. So this is your positive sine curve. If it was a negative sine curve, I'd start here. I'd go down instead of starting up. And my graph would look like that, okay? So that's the only difference with sine and cosine with a negative on the front. All right, now we're going to do a cosine with a phase shift. But again, we're just finding it. We're not going to graph all the way through. So what's your amplitude? 2. Your B is 3. So the period is 2 pi over 3. I would do 2 pi over 3 times a fourth times a half times 3/4 and then end with 2 pi over 3. But then there's a phase shift because you're adding or subtracting here. So 3x minus pi equals 0. 3x equals pi, and x equals pi over 3. So your phase shift is a positive pi over 3. So after you found all 5 of your key points, 0, 2 pi over 3 times a fourth, 2 pi over 3 times a half, 2 pi over 3 times 3/4, and then 2 pi over 3, you would then add, so whatever you get here, you would then add pi over 3 to it. And your cosine curve would start to the right at pi over 3. And it would be at 2 and negative 2. We did a change in amplitude, we did a reflection, we did a change in the phase shift, and we did a change in the period. The last one is a vertical shift. And it is, I like save it for last because it is the last thing you do. If you have all those other things, if you have a phase shift or a reflection, whatever it is, you do all those things, and then at the very end, you do your vertical shift. If you are adding a number outside the parentheses, it causes a shift up, and if you are subtracting a number outside the parentheses, it causes a shift down. It doesn't matter what your original curve is, that's what happens. So if my original curve is sine, and I make that S shape, I start at 0, I go up, down, up, and then there's a +2. I'm going to take all those points and shift them up 2 places, and then move my curve. If I had cosine, which starts at 1, comes down and back up again, and then I had a -3, I'd take all these points and shift them down 3 places. And shift my curve. So when you're doing your homework and notability, feel free to like highlight your answer if you do both. If you want to circle and drag it, you can. It gets messy because you guys write on these a lot. But you can do that as well. But just picture, obviously, when you're taking a test on this, like you can't circle and drag. You got to know that you can use colored pencils, you can use a highlighter to show me your answer, but you're going to have to do both on your, you don't have to, but I would say a lot of the times it's easier to graph it and then shift it. All right, let's do one with all the things. So this one has a negative on the front, which means what? It's flipped upside down. It has a 2, A is 2, well, A is -2 actually, but that means my amplitude is +2. It's cosine, so my curve is that U shape. The 4 is B is 4, so that means the period is 2 pi over 4, or pi over 2. And it has a shift up 1. So I'm going to take my 0, my pi over 2 times a fourth, my pi over 2 times a half, my pi over 2 times 3/4, and the last one, pi over 2. 0 obviously stays as 0. This becomes pi over 8. This becomes pi over 4, 3 pi over 8, and this stays pi over 2. If there was a phase shift, I would add it on. There's not, so these are my 5 key points. 0, pi over 8, pi over 4, 3 pi over 8, pi over 2, amplitude of 2. Now it's a negative cosine. Normally I'd start at 2 and come down, down, up, up. But it's negative, which means I'm going to start at negative 2, go up, up, down, down. And there's the curve without the vertical shift. And now my vertical shift is where? Up 1. So I shift this point up 1, this point up 1, up 1, up 1, and up 1. Two pi over 3. And is there a phase shift? No phase shift. Is there a reflection? No. And then the last thing means? Down 1. So I'd plot my points. I do 2/3 times a fourth, a half, 3/4. Plot your 5 points. It's cosine. It start at 2, come down, down, up, up, and then take everything and shift it down 1. Good? Yes? Okay. All right, last one is a word problem, and this is where your calculators come into play. It says you're riding a Ferris wheel, your height h in feet above the ground at any time t seconds can be modeled by, and it gives you the equation. The Ferris wheel turns for 135 seconds before it stops to let the first passenger off. Use a graphing utility to graph the model. What are the maximum and minimum heights above the ground? Say again. So this doesn't, look at what's next to it. This represents your angle, right? What unit is that? It's radians. So your calculator has to be in radians. So then you go to your y equals, you type that whole sucker in. 25 sine. It's going to open your parentheses here. So you got to be careful. You got to open the parentheses here and then open them again and then close them there. So the sine gets pi over 15. Open the parentheses again. T, which is just x. It's your variable, so it can be anything. Close them again, and then plus 30 at the end. Okay, so I typed that whole I typed it all in here. That's what it looks like. Okay, and then I hit graph. Now I only caught the bottom half of that little scoop, but think about like just the logistics of this function. It's sine, and the plus 30 at the end did what to it? It shifted it up 30. That's why we're cut off, right? So I need to either zoom up my window or adjust it so that I catch the top half of this. So if I did window and I'm worried about my y there. My y has to be at least a bottom of 30. Well, because it'd be 30 plus the phase shift, which is 25. I mean, plus the amplitude. But I got to get up at least 30 plus that 25. So if I went to y max of 60, and then I see what the graph looks like. Now, at least I have part of a curve. I don't even have the whole curve yet, right? You could zoom out again if you wanted to. But at least I see my max and my min, right? So I adjusted my Y window so I could see it. Then it says, what are the maximum and minimum heights? So how do I find those maximum and minimum heights? How do I find max and min on a graph? Trace, or second trace, I go to the calc menu. And if I want to see the max, I hit max. I want the max is all the way over here, so I'm going to the left of that max. So my y's are getting smaller. I know I've passed it. Then I'm going to the right of the max. And I'm hitting enter, and then it wants me to guess, and I say yes. There's my maximum, which is at 55. And then I want my minimum. So I go second, trace, and I go to minimum. And I'm left of it already. I could literally hit enter anywhere here, but I need to get closer anyway. So I'm just going to get closer because I got to go past it. Here. Oops. Then go past it. hit enter, and there's my minimum at 5.